We have now an example how to design a column, steel column. So given the following information, we have a section is W14 by 82, and of course it is hinge at both ends, hinge, and there's a lateral support on the x-axis as shown. So this is lateral support. Determine the maximum allowable load for this, meaning calculate the PA. Of course we can get all of this information for the section from the table. The area, which is 24.1, Rx 6.05, and RY 2.48. I can do that by going to the table. So we go to the table. We have here, this is W14. W14 by 82. So to get the area is 24.1, as you can see, and Rx is 6.05, and RY is 2.48. So that's where you get your information from. And if you look at this is the side elevation, or the elevation, and this is the top elevation. So from the top elevation, see the lateral support is only in the x-axis. So we'll go about the same steps that we followed in the design. Step number one is we'd like to see what is the buckling shape of this column, and we do this by doing the buckling cases study as this one. So with this we have, this is step number one. So you have buckling about YY, and the buckling about YY, you see this is the axis. So we are doing the buckling about Y. So with this buckling, you see an important note is that the point where the lateral support hits the column is always considered to be hinge. Always. So we have here two cases. We have one case here and one case here. Two cases. And this case is for as far as K is concerned. It says hinge and hinge. So hinge is equal to, K value is equal to 1. And the other case is hinge, and this is also hinge. So it is also, the K value is equal to 1. Now let's go to the next, because we would like to calculate the KL over RY. That's what we're trying to do in this case, and here we're trying to get KL over Rx. We always do these two cases, always. So K is, we said, 1 for both of them, for this and this, and L is same, 12 for both of them. This is 12 and this is 12. So all we need to do is just do KL over RY. So K is 1, L is 12 feet, and you need to convert into inches by multiplying by 12, because the denominator is in inches, so you need to divide inch by inch. That's what you're trying to do. And the answer is 58.1. This will be rounded up to 59, so that will be the value first. That is the result of the buckling about YY. Now buckling about XX, we'll do same thing. Again, if you look at the buckling is about XX, so it will be about this, and it will buckle again, this being hinge and this being hinge, it will buckle like so. Now you might ask, what is this? This is the how you see the lateral support. Lateral support is only in the x direction, is not in the y direction. So the buckling will be, this will be the shape of buckling. And the k value, this being hinge and hinge, it is k value is equal to 1. That's what it is. And the length is the entire length here, 24 feet. And Rx is from table 6.05. So if you do the KL over Rx, we get 47 point something, and that is 48. So step number 2 is this was step number 1. So step number 2 will be step number 2 is always get the largest value of KL over R, which in this case is equal to 59. And so we need to go to tables, pick the FA value. So if you go to tables, look for the, again I see there's C36 here, and the next table is C50 here. And if you look at the question, if you go back to the question, you'll see the value is given for is here. It says grade 50. So back to the table. So for 50, and I have the value of 59 for KL over R. 59 is here. So the value is for FA is 2289. So FA 22.89, that is kip per inch square. These are the units for. The units are KSI. So now step number 3 is straightforward. Just to apply this equation, which is FA, maximum allowable axial stress is equal to maximum allowable axial load divided by cross-sectional area. From this we get because we'd like to calculate this is equal to FA multiplied by cross-sectional area. So we know the FA. The FA is this, but we would like to see what the area is equal to. Area is 24. Is 24.1. So that is inch square. So all we need to do is PA is equal to, again watch the units, is 22.89, that is kip per inch square multiplied by 24.1 inch square is equal to, so if we do the cancellation for units, inch square and inch square will cancelled, so we'll be left with kips, and this is equal to, so the multiplication 22.89 multiplied by 24.1 is equal to 551.64, that is kips. So that's the answer for this example. Now we'll do another example. This example will have more cases. So here's the example. Example number 2. So it says we are given a section W10 by 45, and it says the steel strength is 36 kSI, and the supports are as shown. You have lateral supports in X direction at this distance, and lateral supports at Y direction at these distances. So if you take a section or the plan, it will look like that. You will see these are the lateral supports that are provided. And again, the question is to calculate the value of maximum allowable axial load. So step number 1 is, or even before the start of calculation, we need to get the values of the cross-sectional area, which is 13.3, and Rx value is 4.33, and Ry is 2.1. And again, I repeat, these are not going to be given in the question. You have to find them out from the tables. 10 by 45. So if you go to 10 by 45, 1045 will be 1045 will be this. So you see area is 13.3 and Rx is 4.33 and Ry is 2.01. So again, just in case if you are wondering where these numbers are coming from. Okay, so step number 1 is we need to do a study for buckling cases about YY and XX, and that will be. So this is step number 1. Buckling study. So we have about YY. So again, the buckling about YY, you have, this is YY. See YY. So given this to be fixed, this is fixed, and this is fixed. That's given in the question. Okay. So for these fixed cases, now I would like to see in between them how the buckling will look like. And the buckling will go through, this will be fixed hinge, because each lateral support is hinge, and then you have for the hinge fixed. So you have a case of fixed hinge and hinge fix. Of course, it's the same. Hinge fixed, fixed hinge will have a k value of equal to 0.8, and same thing goes for this. So we divide them into cases. So this will be case number 1, case number 2. So the k value is 0.8. I need to watch for the distances. So the first case has a 16 feet for length, and all I need to do is apply this equation, KL over Ry. K is 0.8, and of course the length is 16 feet. You need to convert into inches, divide by 12, and then divide by Ry, which is the value from the properties of the section, which is 2.01. So we get a value of 76.4. We always round them up, so it is 77. Now for case number 2, this being hinge and fixed, so the k value is equal to 0.8. The length is this length, which is 11 feet. So, and apply again the KL over R, Y. The K is 0.8. The length is 11 feet. And you need to convert into inches, multiply by 12. Divide by 2.01. The answer is 52.53. And we round them up to 53. So I have two values here, 77 and 53. Now we come to the buckling about XX, and again see this is X and this is X. So this the lateral supports are this and this, or this and this. So you see this is fixed and this is fixed, of course. So in between, any lateral support will give you hinge and give you hinge. So you have here fixed hinge, then you have hinge, and then hinge fix. So you see, for the first part is fixed hinge, which is 0.8, and the second part is hinge is 1.0, and the third part is hinge fix, which is 0.8. For the length, you have to watch for the, this is 9 given, this is 12, and this is 6. All of them have been this one and this one and this one. Now all you need to do is apply these equations. K over R x. K is again 0.8, length is 9, and conversion must be 12. And of course Rx is 4.33. Put these numbers, you'll get 19.9, so you round them up to 20. Same goes for this. We say the K is 1, and the length is 12. And of course the conversion shouldn't be forgotten. And the Rx is 4.33. Again, you get 33.25. You round it up to 34. And same goes for the third case. The K value is 0.8, and the length is 6. You have to multiply by 12, and the Rx is 4.33. You get that 13.3, round up to 14. Now you see you have this, all of these 5 values. In step number 2, we need to choose the largest value, and the largest value is 77. So this will be the KL over R. So if we go to do step number 2, so step number 2 is, I'll choose the largest KL over R value, and this case is equal to 77. And of course this is unitless, and from 77 we need to, let's go back again and see what is the strength, the quality of the steel. The quality of steel is 36, as you can see here. So we need to go and pick up a value from the tables. It is, because it says it is 36, so this will be C36, and 77 is the KL over R. The KL over R is 77, so look for 77. So here is 77. So 77 is 15.69. 15.69. That is kip per inch square. Now step number 3. Is calculate maximum allowable load, and the equation is equal to FA multiplied by cross-sectional area. So FA is, as we have chosen here, is this. So 15.69 kip per inch square, and the area is equal to, go back here, is equal to 13.3, is 13.3 inch square. So again, if you want to do the cancellation, the inch square go away, you'll be left with kips. So the answer for this will be equal to 15.69 multiplied by 13.3 is equal to 208.677 kips. And that is the answer for this example.